So today we will be discussing the January 2022 Statistics Paper 2. Question number 1. A local pottery makes cups. The number of faulty cups made by the pottery in a week follows a Poisson distribution with a mean of 6. In a randomly chosen week, the probability that there will be at least X faulty cups made is 0.1528. Find the value of X. Okay. So let's first model the question. Question number 1 part is, so what's the first thing? Give a name. What is your variable? So what's the X is the number of okay, so X is the number of faulty cups. Use the exact words they use, number of faulty cups, and what in a week. It's really important that you give your the length of the interval, because in Poisson the length of the interval will define the lambda. Okay, so make sure you give your for each variable. Now when you define X, you must say for what interval that you're defining your X here. So this is for a week, and for a week X follows a Poisson distribution with a mean of 6. So in a randomly chosen week, the probability that there will be at least X faulty cups means what? X is at least means what? At least means it's greater than or equal this X value is equal to 0.1528. Okay, so how do we work with this? You know, when we work with X greater than or equal, we need to work with the cumulative probability table. So X greater than or equal X can be converted to 1 minus probability. Capital X is less than or equal what? X minus 1. So these are theories that you learn in chapter 1 and chapter 2. Okay, so it's equal to 0.1528. So I'll take probability capital X is less than or equal X minus 1. In this side, I get 1 minus 0.1528. So what is 1 minus 0.1528? 0.8472. So now what do you need to do? Go to your Poisson distribution, the cumulative table, go to the column where lambda is 6, and under the cumulative probability, see where you get 0.8472. You should find the column with 0.8472 perfectly. So that means it's not the X equals 8 here. Basically here in our case, we have what? X minus 1 here. So your X minus 1 should be equal to 8. So the 8 value we took from the Poisson cumulative tables, okay, where lambda is 6, and we found 0.8472 perfectly in that table. Okay, do I need to show it? This is the place. The lambda value was 6, right? Yeah, so this is it. Here the lambda value is 6 and 0.8472. So as you can see, 0.8472 is for the X value 8. So however, in our case, the X value is actually X minus 1 here, which means X becomes equal to 9. Okay. Then moving on to part B, they say, use a normal approximation. Okay, so they use the word, use a normal approximation to find the probability that in 6 randomly chosen weeks, the total number of faulty cups made is fewer than 32. Okay, so what do we do here first of all? So give you a new variable. What's your new variable? Y is the number of faulty cups in 6 weeks. So Y follows what? A Poisson distribution with mean what? So for 1 week, the mean is 6. So for 6 weeks, it's 6 times 6, 36. And then you need to make this, you have to convert the, they have told you very clearly to use a approximation, a normal approximation. So in the normal approximation, what happens? The Poisson becomes a normal distribution with mean what? You know, mean and variance are going to be equal to the lambda value, right? Mean is 36, variance is also 36. Remember, this is the sigma square value. Right? Mean is 36 and sigma square is 36. So what do we need to find? They're asking you to find the probability that the Y value, the number of faulty cups made is fewer than 32. So you have to find the probability Y less than 32. So remember, there are a certain set of rules you need to remember here. The first thing is when we are bridging, when we are going from, now we are going to take it from Poisson to normal, right? So we are taking Poisson, we are going from discrete to continuous. So you must do what? You must apply continuity correction. Y less than 32 is going to be either less than 31.5 or less than 32.5. Which one should I choose for y less than 32? Should I go with y less than 31.5 or less than 32.5? If you go 32.5, you're going to pass through 32 because we don't have less than or equal 32. It's not supposed to be equal. So I don't need less than 32.5 would go through 32. So I don't want that. So I mean, we are not supposed to have 32 included. So therefore, we will write here y is less than 31.5. And now we have done the continuity correction. So now it's time to convert this to normal. How do you convert normal? Y becomes z. From 31.5, we subtract the mean, which is 36, and divide by sigma. Sigma is root 36. Remember, this is sigma square here. Okay, so the standard deviation is root 36. So type this in the cal, you can get the whole answer in the calculator, right? Is that less than? So we can go for okay. Now we'll go with statistics. Yeah, so normal distribution with P. Yeah, we'll give the P value. When you type P, you get the area behind that particular person, right? So P value, can I know how much is 31.5 minus 36 over root 36? Minus 0. Exactly? Minus 0.75. So basically, now it's just a matter of giving this in the calculator. So probability is that less than is, you go to the P value. In the calculator, you go to P value and type is minus 0.75. And what do I get? 0.2266. Is this clear? 0.2266. Okay, part C, they say a week is called a poor week if at least X faulty cups are made where X is the value found in part A. So what was the X value we found in part A? X was 9. So basically it's a poor week if at least 9 faulty cups are made. Okay, in a week. Okay, so where X is the value found in part A. So find the probability that in 50 randomly chosen weeks, more than 1 is a poor week. Can you see? So they are saying find the probability that in 50 randomly chosen weeks, basically we are taking 50 weeks and then we are modeling for, they are saying more than 1 is a poor week. Basically we are modeling for what? The number of, are we working with the number of cups now? Faulty cups. No, we are working with the number of weeks. So you have a total of 50 weeks and out of 50, we need to find the probability more than 1 is a poor week. So what comes into your head? This is binomial. This is binomial. So first of all, define your variable. Who is the variable? Let's give a new letter W or A or something. W is what? The number of poor weeks. The number of poor weeks. And do we know the probability? W follows a binomial distribution. What was the total number of, what's the total n here? We are working with 50 weeks. So 50 weeks, and what's the probability of getting a poor week? What's the probability of getting a poor week? The probability of having a poor week is a week where you have at least 9 faulty cups. What's the probability of having at least 9 faulty cups? What's the probability of having a poor week? A poor week is a week where you have at least X faulty cups. Where you have at least X faulty cups is where you have at least 9 faulty cups. What's the probability of having at least 9 faulty cups? 0.1528. You have to get the answer from part A. Okay, 0.1528 is the probability of having more than 9 faulty, at least 9 faulty cups. So that is a poor week. So the probability of a poor week is 0.1528. So then what do we need here? What W value should be what? More than 1, right? Find the probability that in 50 randomly chosen weeks, more than 1 is a poor week. Means we need to find the probability W is more than 1. So W is more than 1 means W is greater than 1, which means in other words, W is less than or equal 1. So you can see here this binomial distribution with this particular probability. Do you think I can use the probability table? No. So we'll have to find these two values manually. So by using the binomial definition, W less than or equal 1 means W equals 0 and W equals 1. So you get both of these values and you add them. So do you remember how to apply the binomial? It's given in your formula sheet as well. X equal x is NCX p to the power x times 1 minus p to the power n minus x. So we'll have to go through this manually. 1 minus, so n is 50, 50C0, right? 50C0, p to the power, p is 0.1528 to the power 0 into 1 minus 0.1528 to the power 50 minus 0 is 50. Plus the next one is 50C1, 0.1528 to the power 1 into 1 minus 0.1528 to the power 50 minus 1 is 49. So type the whole thing, get the answer. Yeah, you'll have to type the whole thing in the cal, right? Zero 0.9975 is correct, right? 50C0. 0.1528 to the power 0 is 1. So I don't need to be bothered with that. 1 minus 0.1528 to the power 50. I should take that. Plus 50C1 times 0.1528 power 1 I should take into 1 minus 0.1528 to the power 49. So that I only type this part, then I have to do 1 minus of that answer. 1 minus answer 0.9974876. So 0.9975 is the answer. Okay, so now we move on to question number 2. The continuous random variable x has a cumulative density function given by, okay, so capital Fx is given by x plus k divided by 4k, okay, and x is defined between minus k to x is defined from minus k to 3k. Okay, they say here specify fully in terms of k the probability density function of x. So they have given you the cumulative distribution function. From the CDF, how do we come to the PDF? What's the technique? We must integrate or differentiate. We must differentiate from the probability density function. When we go to capital Fx, we integrate it. Then from the capital Fx to simple Fx, we must differentiate. Okay, so you need to remember the theory here. So question number 2, capital Fx is given as x plus k over 4k. So you need to differentiate. So when we differentiate x plus k over 4k, so differentiate d by dx of capital Fx. D by dx means differentiate capital Fx with respect to x. Okay. So how do we differentiate x plus k over 4k? So we can differentiate this by using, you can see that we have a fraction here. So we could use the, no, we don't need to go for product rule actually here. K is a constant, right? Where k is a positive constant. So just be careful here. 4k doesn't mean that we need to use a quotient rule or anything here. Basically 4k, you could write this as 1 over 4k times x plus k, right? Basically this is, let me write over here, 1 over 4k times x plus k. 1 over 4k is a constant. 1 over 4k is a constant. So then you leave that aside and differentiate the x plus k. What happens when you differentiate x plus k? X differentiation is 1 and plus k is 0. So basically it's just 1 over 4k into 1. You need to leave the constant, multiplication constant, just leave it there. So 1 over 4k into 1 is 1 over 4k. So specify fully. They're asking you to specify the probability density function fully. How do you fully specify a probability density function? You know, you had write it down nicely. You write it down in this manner. You define it for all the x values. So your PDF is going to be 1 over 4k from where to where? It's going to be 1 over 4k from, for x values between minus k to 3k. For x values greater than or equal minus k, less than or equal 3k, and 0 otherwise. Your PDF will be 0 for all other x values. Is that clear? Then they say in the next part, I think you need to realize here that this is actually what? When you see a now do you see 1 over 4k is actually a constant? Your PDF is in terms of a constant, right? It doesn't have any x value in it. Okay. So basically, what does this remind you of? This is a what kind of a PDF are we talking about here? What kind of PDF are we talking about here? Now there are specifically when it comes to PDFs, if it's in terms of x, okay, then the graph is, I mean, you can have a straight line graph. I mean, you can have a graph with a gradient that goes like this for your PDF, or I mean, but in this case, 1 over 4k is what kind of a graph? 4k is a constant. So it's actually a y equal k kind, y equals a constant, right? So y equals a constant means it's a graph that goes like this, a straight line, a flat line, which means this is what, there's a special name we give for this. What is it? This is the continuous uniform distribution. Do you remember continuous uniform distribution, the rectangle graph? Okay, so then we learn about this especially in S2, right? So part B, find in terms of the value of Ex. So for this rectangular distribution, for continuous uniform distribution, to find Ex, we had the rule. What was the rule? It was A plus B over 2, right? When X follows a uniform distribution from A to B, do you remember? Simple fx was written as 1 over b minus a. I think you can see here 1 over b minus a works here, right? 3k minus k. Can you see b minus a? 3k minus k is 1 over 4. And ex is going to be a plus b divided by 2. Can you see? It's a plus b divided by 2. So your a is going to be minus k. Your b is going to be 3k. Add and divide by 2. Minus k plus 3k is 2k. 2k divided by 2 is 1k. Is that clear? It's just 1 mark. You need to realize by looking at this that we have actually got a continuous uniform distribution. That's the important thing. You need to realize that we actually achieved a continuous uniform distribution. Okay. Then part C, they ask you to find, show that variance x is 4 over 3 k square. How do we show yx? For yx also in continuous uniform distribution, we have a special formula. What was it? So you have to turn your books, you need to remember the equations. For a continuous uniform distribution, it was b minus a square over 12. Check on this. Okay, Ex is a plus b over 2. Variance x is b minus a square over 12. Can you input the value? B value is the 3k. Minus a value is minus k. Square over 12. Get the answer? So 3k minus k is 4k. 4k whole thing square over 12. 4 becomes 16 when you square, and this is k square over 12. 16 over 12 is 4 over 3 k square. Is that clear? Okay, the important thing is to identify the distribution, or else you wouldn't be able to do any of these things if you didn't identify this as continuous uniform. Okay, then the next thing they say, find in terms of the value of e times 3x square. Okay, how do I get the value of e times 3x square? E times 3x square is, in other words, 3 times e of x square. How do I find the value of e of x square? So we have a special equation for this part D. So, we have this equation for yx, right? Who is yx? E x square minus ex whole thing square. Ex square minus ex whole thing square. So variance x, we just found it out. 4 over 3 k square. Ex whole thing, ex square is what we are actually trying to find. Ex whole thing square is, what was ex value? Ex value was k. So k square. Take it to the other side. 4 over 3 k square plus k square equals e of x square. 4 over 3 k square plus k square is 7 over 3 k square is e of x square. So is that what we are supposed to find? No, they want us to find e of 3x square, which is 3 times ex square. So 3 times the ex square value we just found. Ex square is 7 over 3 k square. The 3 to 3 will cancel. The answer is 7k square. Is this clear? Okay, moving on to question number 3. A photocopier in a school is known to break down at a mean rate of 8 times per week. Okay, so you can clearly see what they have given you an average rate of breaking down per week. So when you see this, the moment you see this, you realize it's about distribution. It's a Poisson distribution because in binomial, they give you a fixed number of trials and a constant probability of success. But here, it's a mean rate of breaking down 8 times per week. So this is the interval. They say give a reason why a Poisson distribution could be used to model the number of breakdowns. So then we have some certain assumptions that need to be true in order to apply for a Poisson distribution, right? So what are they? First we can see the events are independent, right? In this case, what? What the breaking down, right? So the breaking down, the machine breaking down, what occurs independently and also you can see it occurs at a constant rate. Can you see? Because in Poisson, it's really important that you have a constant average rate of the event happening. So it's really important. So we can assume the breakdowns are independent. The breakdowns are independent and they occur at a constant rate. So something like that. Okay, the breakdowns are part A. The breakdowns are independent. Independent events occurring at a constant rate. Okay, so these are the assumptions that we use. Part B, the head teacher of the school replaces the photocopier with a refurbished one and wants to find out if the rate of breakdowns has increased or decreased. They use the word both. I mean, they use both the words. So then they are replacing the old one with a new one and they want to see if the rate of breakdowns has increased or decreased. Write down suitable null and alternative hypothesis that the head teacher should use. So what's H0 now? You know, we have definite formats for H0 and H1, right? So for Poisson, we model the lambda. So what's the lambda here? First one, H0 is lambda definitely equal. So what's the lambda value that they have given to us at this point? Lambda is 8. Okay, H0 lambda is 8. And H1, so for H1, we have 3 formats, either lambda greater than or lambda less than or lambda not equal. So out of those 3 options, which one do we use? Not equal, because they say here they want to check whether it has whether the breakdowns has increased or decreased. They have not gone in a very specific direction. So both ends are given. Therefore, lambda is not equal to 8 should be your H1. Okay. Then moving to the next part, the refurbished photocopier was monitored for the first week after it was installed. Using a 5% level of significance, find the critical region to test whether the rate of breakdowns has now changed. Okay, so you are supposed to now find what? You're supposed to find the critical region. So to find the critical region, what do? We assume H0 is true, right? We assume H0 is true. And then we take the distribution. So what is X here? X is the number of breakdowns, because X is the number of times the machine breaks down, right? Number of breakdowns per week, because we are measuring it for per week. So we assume, then we know that X follows a Poisson distribution with lambda 8. Is that clear? So this is our distribution. Okay, now I need to find the critical region here. So you know, if it's a two-tailed test, we have how many critical regions? We have critical regions at both ends. So your significance level, you need to divide it by 2. So what's our significance level? 5%. So you take it to both the sides. So each side gets how much percentage? 2.5%. Take 2.5% on either end and let's find the critical region. So go to the tables. Go to the tables. Okay, let's go to the tables and use Poisson distribution. Lambda is Lambda is 8. Okay, here Poisson distribution, lambda is 8. Can you see? So in this column, lambda is 8. So I need to cover in the back end an area of 0.025. Right, 0.025. How much can I go? I think you can see x equals 0 is covered, x equals 1 is covered, x equals 2 is 0.013 is 1.38%, right? Which is less than. But can I go to x equals 3? No, it's 4.24%, right? We can't go for 5%, we need to go for 2.5%. So the area that is comes inside 2.5% is 0.0138. You see it? So basically, we'll write both. We need to show, we had write both of them and show that one person is in and one person is out. And you need to show both of them. Give me these values again. So probability x is less than or equal to was how much again? 0.0138. Okay, which is 1.38%. And which is what? Less than the 2.5%. The other one, you have to write it and show. The other value is what? X is less than or equal 3 because we need to show the value that is in and outside. So what is it? 0.0424, which is 4.24%. And therefore, what do you see? It is jumping outside your critical region. So therefore, what should be the critical region in that case? Okay, so this one is jumping outside, so we can't take that. So this is correct. So then our critical values are inside in the left tail. It's going to be x equals 0, 1, and 2. Okay, now check the other side also similarly. Check the other side. So in the other side, when you take 2.5% here, what's the behind area? The behind area is 97.5, right? Behind area, because we are taking the areas from the cumulative distribution table. So 97.5 is the behind area. So basically to be in the critical region, the area needs to be more than 97.5. So take the two values in here who is more than 97.5. The value just after 97.5 and the value just before 97.5 percentage. So how much is it? 97 for lambda 8. So you can see here 0.97.5. So I think 9658, 96.58 and 9827. However, you do realize here that this x value is x less than or equal 13. To get the probability x less than or equal 13, that means x is greater than or equal 14, isn't it? So then you write here for the first one, probability x is greater than or equal 14 is what we get as 1 minus x is less than or equal 13, isn't it? Okay, so what was that value here again? 0.9658. This is the value who is outside the critical. No, yeah, it's jumping out. Yeah, how much is it? 0.0342, which is 3.42%, which is what? More than 2.5%. That means are you in the critical region? No, you are outside. You are over here. This value is over here. Check the other value. X is greater than or equal 15. X is greater than or equal 15 is 1 minus x is less than or equal 14, which is what? 1 minus 9827. How much is it? 0.0173, which is 1.73%. Very clearly, it is less than your 2.5%, and thereby it is in the critical region. So this is in the critical region. Therefore, so you can now start talking about your critical regions. So what are the critical regions? X is less than or equal to, or the other one is x is greater than or equal 15. So these are the critical regions. So any x value in these critical regions would make you reject the null hypothesis. Is that clear? Part D. Find the actual significance level of the test of a test based on the critical region from part C. So part C, we found our critical regions. So they wanted to find the actual significance level. So how do you find the actual significance level? Get the actual probability that we use. X less than or equal to is 1.38%, and the other one, x greater than or equal to 15 is 1.73%. Add those two probabilities, 1.38%, adding with 1.73%. How much is it? 3.11%. So out of the 5%, the actual significance that we have taken here is 3.11%. Is that clear? And moving on to the next part, they say During the first week after it was installed, there were 4 breakdowns. Comment on this finding in the light of the critical region found in part C. So there basically the X value is 4 in part C. Sorry, in part E, they say the X value is 4. So based on X value equal 4, what do you think? Is it falling into the critical region or is it outside? It's not in the critical region, right? X equal 4 doesn't fall for any of these two. So basically what happens? X equal 4 is outside the critical region, isn't it? It's not in the, you can say it's not in the critical region, right? It's outside the critical region. Therefore, do we have evidence or insufficient evidence? When you are outside the in critical region, there is insufficient evidence. There is insufficient evidence. There is insufficient evidence to reject H now. That means we can't reject the null hypothesis. So we'll have to go with that. That means, but in other words, we don't have enough evidence to say what the breakdowns has increased or decreased. Basically, we can say there is no evidence to say that the refurbishment, right? Because you have the refurbishment has changed the breakdown rate, isn't it? There is no evidence because you need to give a statement regarding the question also. There is no evidence to say that the refurbishment, use the words they use in the question, okay, has changed the breakdown rate, the mean, what's the word they use, the refurbishment, yeah, mean rate, yeah, the mean breakdown rate. Is this clear? So give definitely you need to give a statement with respect to the question. Okay, with respect to the words they have used, you must give a clear conclusion in this particular question. Okay. Question number 4, the continuous random variable x has a probability density function given by, okay, can you see the probability density function here? There are, you can see your PDF is broken into 3 sections, basically, right? I mean, there are for 3 sets of x values. Okay, so for these 3 sets of x values, you have to draw your, I think they have a certain part is sketch fx for all values of x. So first thing you need to realize is look at these three functions and realize what type of sketches you are going to draw. Is it a straight line? Is it a curved line? What are we going to draw? Look at the first one, half k times x minus 1. Here k is a positive constant. Okay, so half k is a constant times x minus 1. What do you think this is? When it's x minus 1, it should definitely be a straight line. A straight line. Here just k, y equal k is a constant, which is again a straight line, a horizontal straight line, isn't it? Y equal k. And the next one, y equal 1 over 4k, 10 minus x. Again, there's x involved. So that's just a x involved means it's a straight line. You don't have any x square here because if you have x square, then you should know it's a quadratic function. Anyway, here it's all 3 straight lines that I need to consider. So basically, to draw a straight line like this particular one, what I'll do is, do I need to take many coordinates into account here? No, just knowing the two end x values and just getting the two respective y values for the two con x values is more than enough. So what you do is consider the first graph. When x equal 1, get the y value. What's the y value? Y equal half k times 1 minus 1, right? For this graph, for the first one, replace x with 1. What do we get? Y is 0. Then replace x with 3. What do we get? Y equals half. K is half k times x minus 1, 3 minus 1. So 3 minus 1 is, I get here half into k into 3 minus 1 is 2, which gives me what? Y equals k. Do you see the two coordinates here? Starting coordinate of this particular graph. So for x values between 1 to 3, the starting coordinate is x is 1, y is 0. The ending coordinate is x is 3, y is k. Do you see it? So you can kind of like start drawing the sketch on the corner and we need to keep continuing it. So starting x value 1, ending x value 3 here. At 1, you have 0, right? 1, comma 0 and 3, comma k. Is that okay? So let's say k is over here. So basically I have a straight line. Okay, right. Then the next one. For x value between 3 to 6, what do we have? Y equal k. So y equals k means what? It's a horizontal straight line. It's a horizontal straight line because there's no x variation here. Y equal k. So between 3 to 6. So in between 3 to 6. In between 3 to 6. Okay, so until like over here, what happens? We have a straight line x y equal k. So can't you draw the straight line y equal k? So it should go like this, right? Okay, so then after the horizontal straight line, go to the next part of this graph. So that is x value is between 6 and 10. So for x value is between 6 and 10, take the straight line, input the first x value as 6 because I want to see how the graph continues at x equals 6. So y equals 1 over 4 k times 10 minus 6. How much is it? 10 minus 6 is 4. 1 over 4k into 4 is y equals k, right? Do you agree? 1 over 4 k times 4. The 4 and 4 will cancel. So y equals k. Basically, at 6, the y coordinate is k. And at 10, when x equals to 10, 1 over 4 k times 10 minus x. For x, I'll use 10. So what do I get here? Y equals 0. Basically, when x is 10, y is 0. So you see, so go back to this graph and the next part of the graph needs to continue from 6 to 10. So it needs to be a little bit slightly longer than the previous part, right? So 6 to 10, 7, 8, 9, 10, there's more here, right? Okay, so how does it go? The starting coordinate is 6, comma k over here. Yeah, so it's definitely starting at the place where the other graph ends. Do you see? Okay, it's not the case in all cases. Okay, just be careful. It's not the case. Sometimes the graph can be discontinuous. In this case, the graph continues. Okay, and then the ending point is at 10, comma 0. So basically over here. So draw the graph. So you have the final graph that looks like this. Is this clear? So this is the PDF, the sketch of the PDF. Okay. Then moving to the next part, they say, show that k equal 1 over 6. Okay. How do we show that k equals to 1 over 6? Part B. How do I show that k is 1 over 6? Basically, what do we know about a PDF? In a PDF, the total area under the graph must be 1. So then basically you could get the area under the graph. You would take area of a trapezium and get the value of k, or else you can integrate each of these parts separately from 1 to 3 integration, plus from 3 to 6 integration, plus from 6 to 10, which is time consuming. So I will go with the area of a trapezium. So area is equal to what? Half a plus b into height. That is the into h. That's the area of a trapezium. Half a and b are the two parallel lines. Can I know the length of the two parallel lines? What's the length of this parallel line? Is it 10? No, the length of this parallel line is 9, 10 to 1. Okay, 10 minus 1, the length is 9. Plus, can I know the length of this other parallel line from 3 to 6? 3. Multiply by the height is k. So the area is, the total area is equal to 1. So make k the subject, 9 plus 3. That is half times 9 plus 3 is 12 times k equals 1. Half into 12 is 6. 6 times k equals 1, which gives me k equals to 1 over 6. Is that clear? K equals to 1 over 6. Okay, which is the show that. So make sure, even though it's a show that, to write extra steps to show all stages of your working so that you get all the marks. Okay, show that. Show that show that you need to make sure you show the steps very clearly. Okay. Part C, specify fully the cumulative distribution function of capital F(x) of x. Okay, you can see the majority of the marks are going to this question. Can you see? So you have 7 marks for this question. Basically, they want you to create the capital F(x). So we have done this. Let's create the capital F(x). Part C, capital F(x), the first graph. Okay, can you all quickly specify me the simple F(x) graph? Okay, so I wrote the simple F(x) here again so that I can easily refer it back. Okay, there's no need to write it as a part of the answer. Okay, just I wrote it here so I can write the answer easily by looking at it. Okay, how do we create capital Fx for x values between 1 to 3? Let's start for x values between 1 to 3. So how do you create capital Fx? We integrate, what are the rules? We integrate from the lower limit. The lower limit is 1 and the upper limit we use as x. The upper limit we use as x. So basically x is supposed to be anything in between what? 1 and 3. Okay, so when you integrate, you create the you get the capital Fx. So you are supposed to integrate what? Half k times x minus 1. So what does capital Fx do? It gives you the cumulative probability. Basically, if you give any x value into this function, basically the x value, you will get the area from 1 until that point. The total area covered by the graph from 1 until that point. Okay, so can you all integrate quickly? What do we get here? Half k is a constant. Keep it out. Integration of x is x square over 2. Integration of 1 is x. Do you agree with me? From 1 to x. What do we get here? Half k, keeping it out. When I replace x with x, it's the same thing, right? X square over 2 minus x. There's no difference in the first part. Minus the next one, you replace x with 1. What do we get? 1 square over 2 is 1 square is 1 over 2 minus 1. How much do we get here? X square over 2 minus x minus half minus 1 is minus half, right? Minus into minus half is plus half. Is that clear? Okay, so now what happens? K value is known, right? We know k value is how much? 1 over 6. Shall we input the k value as 1 over 6? Input the, open the bracket, or else we can say this is 1 over 12, right? 1 over 12, and you could take a 2 out from here, or else you could input this inside. There's actually no problem. Shall I take a 2 outside? A half. If I take a half outside from the bracket, you must know that when you take a half out, it means you are multiplying the inside function by 2. Are you aware of that? When you take a half out, it means you are multiplying inside with 2. So 2 times x square over 2 is x square minus 2x plus half into 2 is 1. Do you get what I'm doing? When you take a half out, when you take a half out, basically you multiply everyone by 2, or else you could take 2 as the common denominator and then take the 2 out. So then you get here x square minus 2x plus 1. If you take 2 as the common denominator, anything is okay. So I get here 1 over 12 into half is 1 over 24 times x square minus 2x plus 1. This is the simplified answer for capital Fx for x values between 1 to 3. So what does it tell you? Basically, if you use any x value between 1 to 3, say you use x value of 2, what happens? If you use x as 2 here, what do you get? You get the area under the graph between where we are from 1 to 2. You get the area covered by the graph in the region 1 to 2. You get this area basically. I'm just saying, I just randomly said x is 2. If you say x is 2 and you replace the x value as 2 here, you would get a figure answer. That figure answer you get is the area covered from 1 to 2. Okay, right, just telling you, we don't need to do that. Okay, I just that's not what they want. Okay, capital Fx is done for the first part. Continue, we need to keep on doing capital Fx for the other two parts as well. Okay, so for the other part, for x value between 3 to 6, okay, how do we calculate capital Fx? Basically the rule is still the same. Capital Fx, what do? We must integrate, right? We must integrate from the lower limit until x. So in this case, what's x? The lower limit is not 1 now. What's the lower limit now? Now the lower limit is 3. From 3 to x, and here x is now supposed to be what? Any number between 3 and 6. Okay, and then you integrate. What's the function? We just have a k, right? So k is the constant, which we found as how much? K is a constant which we found as 1 over 6. Take it out and you are integrating simply 1, right, with respect to x. Because you know constants when it's a constant k, you can take it out of the integration mark or you can keep it in. Basically, when you integrate the 1, what do you get? 1 over 6 times x. Give the limits 3 to x. 1 over 6 times what happens here? X minus 3, right? When you input the limits, first you replace x with x minus, then you replace x with 3. So I have given the limits here. Now, taking a look at this, is this the correct capital Fx for x values between 3 to 6? Now what happens if you give x value? Say I give x value 4 here. If you give x value 4 here, what do we get? When I use x as 4 here, I get the area from where to where? I get the area from 3 to 4. But when in the graph, when we say capital F4, what are we supposed to get actually? When we actually say capital F4, from the starting point is not 0. The starting point is 1. Okay, be careful there. The starting point is 1. So when you use capital F4 here, we are supposed to get the area from the start until where? Until 4. We are supposed to get the area from the starting point until 4. Okay, so I need this entire, this is capital F4. This whole area is capital F. I'm just giving an example here. Okay, this is not what you need to do. But to give you an example, this is not done. It's not complete. Basically, but if you use F4 here, are we going to get the area from 1 to 4? No, we get the area from 3 to 4. Do you see? Now in my graph, if I use F4, I basically get only this small area. But capital F4 is supposed to also have this in it. So what should we do? We should add the capital F3 of the previous section. The previous graph, I think you found capital Fx of the previous part, right? Get capital F3 here. When you get capital F3 here, what does it give you? It gives you the area of this full triangle. Add that to this particular X area. And then when you give F4, you are, basically you have to add this area of the full triangle to this answer that we have. This answer. So then basically, then when you use F4, you will get the area from this, you get the area from 3 to 4, and the other area we have manually added it. Okay. Let me erase all of this. I hope you understood that this is a theory you learn in your book. There's 2 book. Okay, so let's add this, get capital F3. So basically this, you have to add the what? With this, you must add the capital F3. Do you realize? With this, you must add the capital F3 value to this. Then only you can get F4, F5, F6, you can get it correctly, because we need it. When you apply capital Fx, it means I must get the area from the very beginning. Okay, so can you all get me the capital F3 value here from this graph? How much is capital F3? One over 24, 3 square minus 2 times 3 plus 1. How much is capital F3? How much? Simply 1 over 6. Capital F3 is 1 over 6. Okay. So add it all. 1 over 6 times x minus 3 plus 1 over 6. I can take 1 over 6 out as common. X minus 3 plus 1. Do you agree? So 1 over 6 times x minus 2. So now this gives me the correct capital Fx. So if I give for this particular x value capital F4, I get the area from 1 to 4. Do you agree? If I give here x is 4 now, I get the area not from 3 to 4, but from 1 to 4, because I have added the extra part. Okay, let's continue. We are not done yet. So now I have to find the capital Fx for the third part. So what do you think I should, how should I use capital Fx for the third part? For x values between 6 to 10. Integrate from where to where? The graph is given from 6 to 10. So basically, you integrate the graph from the lower limit to x, where x represents any value between 6 and 10. Now x represents any value between 6 and 10. Are you with me? Okay. So then we get here 1 over 4k times 10 minus x. Okay, so integrate 1 over 4 and k are constants. I'll take it out. What happens when you integrate 10? You get 10x minus x square over 2 from 6 to x. 1 over 4k, 10x when you integrate, it's 10x. When you are first replacing all the x by x, so there's no difference there. Minus the next one, you replace all the x values with 6. So 10 times 6 minus 6 square over 2. (10x minus x square over 2). What happens here? Can I know the simplified answer? 10 times 6, 60 minus 36 over 2. How much is it? Minus 12. Final answer. Okay, so from here also shall we simplify? Okay, we are not done with this yet. We are not done with this yet. Why? Now, when you use the x value here, take any x value between 6 and 10. So let's say 8. What happens if you use if x is 8 here? This value is wrong. Can you tell me the correct answer? 10 into 6 minus 6 square over 2. How much? This is 42. Can I have the... so minus 42 here. 10 into 6 is, 60 minus 36 over 18. Yeah. Okay, is that part okay? But we are not done. This is not the correct capital Fx answer, right? Why? Now, let's think, for example, we use the x value in between 6 and 10, like let's say 8. So if you use capital F8 here, you know, capital F8 is supposed to give you what? The area from the very beginning, from x equal 1 to x equal 8. But when we use x equal 8 here, what area am I getting? I'm getting the area only from 6 to 8, right? I'm only getting the area from 6 to 8. If I use x as 8 from the graph that I got, I only get this area. But capital F8 is supposed to be what? Is it only supposed to be this small part? No, it's supposed to give the area from the very beginning until 8. Like all these should be. Basically, what should I do? From 6 to 8, from 6 to x area, I have to add the previous area. What is it? The previous area I can use capital F6. From whom do I find capital F6? From the, not from this one, not from this one, not from 1 to 3, go from 1 to 6. 3 to 6. When you go from 3 to 6, you can apply F6. Now you have already fixed this, right? This graph is already fixed to give you the total area. Whatever x value you give between 3 and x, we have added and made sure that it gives us the area starting from 1. Isn't it? We have fixed it. It gives us the area starting from 1. So basically, I have to go to this graph and give what? F6. So when I give F6, I get the area completely behind 6, from 1 to 6. So I get here F6 equals 6 minus 2. Okay, I need the full area. Capital F6 means the total, the full area from 1 to 6. What do I get here? 1 over 6, 6 minus 2 is 4, which is 2 over 3. Do you realize 2 over 3 is the total area? The total area from here, this full area is 2 over 3, this area. Okay, so make sure that even though this says 3 to 6 here, you realize that we have added the previous part behind. So therefore, this gives the, when you give x value between 3 to 6, you don't just get the area from 3 to that x value. No, you get the area from 1 because we have added the previous part. Okay, so basically when I gave f6 here, I'm not getting just from 3 to 6. I get from 3 to 6 plus the behind area, which we have already added into this. We have already input it inside here. So 2 over 3 is the full area behind 6. So basically, to get the capital Fx correctly, I had to add F6 here. Do you agree? I had to add F6 here, which is how much now? We just found F6 is how much? 2 over 3. Shall we replace the k value also with 1 over 6 and simplify? Okay, I'm not having spaces, so I'll move over here. Capital Fx equals 1 over 4 into k is 1 over 6. 10x minus x square over 2 minus 42. We need to simplify this. So 1 over 48, right? Simplify this. 1 over 48. Shall I take a half out from this inside? Then I get 10 times 2, 20x. X square over 2 into 2 is x square. 42 times 2 is... Sorry, 6 times 4 is 24. I'm sorry. 6 times 4 is 24. Yeah, sorry. Yeah, 6 times 4 is 24. Okay, and then I take the half out. Yeah, sorry. Then we get 20x minus x square minus 42 into 2 is 84. Plus 2 over 3. Then here shall I make the denominator here also 48. 3 times how much is 48? 3 times 16 is 48. So we can now take 1 over 48 out as common and have 20x minus x square minus 84 plus 2 times 16 is 32. Add them all together. How much is it? Minus x square, I'll rearrange, plus 20x. Minus 84 plus 32 is minus 52. That's it. So now I have added the previous area and this capital Fx. Basically, if I use any x value between 6 and 10, say I use F8, this gives me what? Only the area from 6 to 8. No, I have added the behind area. So this gives me the area from 1 to 8. Okay, so this is the capital Fx. So now we are not done yet. We need to specify our capital Fx fully, 7 marks. They ask us to specify capital Fx fully here, right? Yeah, so specify means you have to write the function. Shall we write the function? So write capital Fx equal. You remember that you should write starting from who is the very first value? 0. 0 for what x values? So 0 for x values less than 1. And then for x values between 1 to 6, 1 to 3, your capital Fx was 1 over 24, x square minus 2x plus 1, right? Write down next part, 1 over 24 times x square minus 2x plus 1. This is for x values greater than or equal 1, less than or equal 3. Next part, from 3 to 6, I have got it over here, right? From 3 to 6, capital Fx is 1 over 6 times x minus 2. This is for x values between 3 to 6. And the next one, between 6 to 10. I have got the answer here, right? 1 over 48. 1 over 48 minus x square plus 20x minus 52. And this is for x values between 6 to 10. And then the other one is 1. You remember capital Fx, it's 1 for x values bigger than 10. Because after x value bigger than 10, your capital Fx is 1. Okay, you don't reach probabilities more than 1. So this is the full specification. This is how you fully specify capital Fx. This is clear? 7 marks. Okay, so the question, there's a question here regarding that the equal mark is not there for 6 here. But we have used the limits here 6 to x, right? So basically the answer is that this is not a discrete distribution. Now in a discrete distribution, if you say x greater than 6, then we immediately start at 7. But in a continuous distribution, when they say x greater than 6, you can take the immediate next decimal value also, because for continuous, we take all values in the range. Each and every single value inside the range comes. So there are infinite values between 6 to 10. Okay, so in continuous graphs, even though the equal mark is not there, you can still consider taking your values from that point. The difference is only in discrete. In discrete, if they say x greater than 6, then you can't take x with 6. You have to start at 7. But in continuous, you can definitely start at 6. Okay. Then shall we go for the next part? Next one, they say given that Ex is 61 over 12, find the probability X is greater than Ex. Okay. So how do we find the probability X is greater than Ex? And it's just 2 marks. Think about it. So basically, how do we do it? Part D. They want you to find the probability X is greater than Ex is 61 over 12. Can I know 61 over 12 falls to which, the decimal figure? Because we need to see which falls to which range. Which value? 5 point? Yeah, it's a decimal figure, but don't use a decimal figure. At this point, all I need to know is what is to which range it falls. Yeah, this is you said 5.08, whatever. Okay, anyway, what we really need to realize is, okay, it's in the range between 3 to 6. So I need the area greater than. However, you do realize I just found whom? I just found capital Fx. Capital Fx gives me the area what? Behind a certain x value. So if I want to find the area greater than, what is the easiest way to use capital Fx here? We can do 1 minus the area behind this value. So the area behind means what? It's capital Fx. Isn't it? So if you want to get now the greater than area can be found by using 1 minus the behind area. And since this is uniform, since this is continuous, the equal mark being here, not being here does not make an effect. Okay. So we can work with decimals. So basically capital F 61 over 12. To use 61 over 12, to which range do I go out of all these 3? Now I have my capital Fx fully specified here. Which function do I use? I have to use the capital Fx from 3 to 6. And you, because 61 over 12 is some 5.08 figure, which means it falls to this one. So use your x value as what? 61 over 12. Here you immediately get the area behind 61 over 12. Okay, so use 1 over 6x minus 2 here. Okay, so I get here 1 minus 1 over 6x minus 2, right? So x is how much? 61 over 12 X minus 2, right? 1 over 6 x minus 2 was the capital Fx, isn't it? Now type it in the cal. 1 over 1 minus 1 over 6 times 61 over 12 minus 2. How much is it? Final answer 35 over 70, which you give it to give me to decimals. 0.4861. Is this clear? Okay, then the next one, describe the skewness of the distribution, giving a reason for your answer. Okay, so how do we describe the skewness of this distribution? Okay, normally how do we describe skewness? In S1, you have learned about skewness. You can describe skewness through quartiles. You can describe skewness through mean, median. Okay, so you need to, now in this case, I think you can see the EX is the mean. So they have given you the mean. Basically, to compare the skewness, you need to find what? The median. If you have an idea about where the median is, you can give an idea about comparing the mean and median. You can give an answer about the skewness. First of all, can you all remind me about the skewness rule? If mean is greater than median, it's a what skew? Because I just wanted to remind me. Mean greater than median means it's a positive skew. Okay, you need to remember the rules though. If mean is less than median, it's a negative skew. If mean is equal to median, there is no skewness. It's symmetric. The graph is symmetric if mean equal mean. Now in our graph, do you by any chance think it's symmetric? Looking at the shape. Okay, so I think when you saw the shape, you can see it was not a symmetrical trapezium, right? Looking at the shape very clearly, you can see one side it's going further, right? So it is not symmetric. Definitely there is a skewness. So now you need to check on whether your mean is greater than median or whether it is less than median. Okay, so how do we find, how do we come in, get that? We actually found the probability that X is greater than the mean, right? The area. You see here, now we know our mean value is 61 over 12, the mean. So the area greater than the mean is how much? So in our graph, the area greater than the mean value is how much? 0.4861. So this area is 0.4861, which is like 48.61%, right? Now, you know, median covers what? Exactly 50%. So what do you think here? Your median is it now? This is the mean value. This is the mean value. Is your median going to be after the mean or is it going to be before the mean? Median covers exactly 50%, right? 50%, 50%. Okay. So this the area after the mean is 48.61%. Okay. So is your median going to be after the mean or is it going to be before? The thing is, this area is 48.61. So if you go after the mean, if you take a value, this area will be lesser than 48.61, right? If you go after the mean, now this area after this line is 48.61. So if you want 50% area, then it needs to be slightly behind, right? To get the 50%, which means mean is a little bit behind the mean. Okay, it's just 2 marks. Are we going to manually calculate the mean? Definitely no. Okay, so you need to realize your median is what? Median is less than, or you can say mean is greater than the median, because your median comes here, the 50% area, because there's a 2% behind here. There's a 2% area behind here to get the 50%, somewhere like roughly 2 points. There's another point percentage anyway. So what I want you to realize is the median is behind the mean. So in other words, which one of these conditions are we talking about? Mean is greater than the median. Right? Isn't it? Mean is greater than median. Therefore, what skewness? So we have positive skewness. Okay. Or you can give a, do they say describe the skewness giving a reason? Yeah, here give a reason. So give the reason. What's the reason? You can comment on it with the probability, right? So comment on it with the probability. What can you say? Probability X is greater than 61 over 12 is how much? 0.4861, or it's 48.61%, which is what? Less than the 50%. But remember, we are taking the area from the front, greater than area, not the less than. So therefore, what do you realize? Mean is greater than median. Therefore, what skewness? Positive skewness. Okay, so positive skewness. Is this clear? By the way, I'm writing my answers all over the place here. You're not supposed to write in any of these areas. Okay, so just because I write over here, you might write everywhere in the page. You shouldn't do that. They have told you not to write in these outside edges. Okay, is this clear? Are my instructions clear to y'all? Okay. Question number 5. Applicants for a pilot training program with a passenger airline are screened for color blindness. Past records show that the proportion of applicants identified as colorblind is 0.045. Write down a suitable model for the distribution of the number of applicants identified as colorblind from a total of n applicants. Okay, so what's the suitable model in this case? So they say there is a total of n applicants. Basically, they are telling you that there is a fixed number. And then they say past records show that the proportion of applicants identified as colorblind is 0.04. So basically, that's the probability of a person being colorblind. So what distribution do you think we do? Do you think we have Poisson here? No, there's no interval here. So basically, here we have a binomial distribution. So you can write fifth one part A. It's a binomial distribution. And what are the parameters? N, the number of trials is n, and probability of success or the probability of being colorblind is 0.045. Okay, and yeah, better you define X also. X is what? Shall we write from there? X is the number of applicants who are identified as colorblind. And X follows a binomial distribution, n, probability of success 0.045. Agreed? Part B, state one assumption necessary for this distribution to be a suitable model of this situation. Basically, one assumption for it to be for this to be binomial. So what are the main assumptions? Just one. Mainly we say number one, independent is one assumption. The other one, yeah, don't say the fixed number of trials because they have already used it. Just give a main assumption. Give the state one assumption necessary, like a main assumption. Independence is definitely one main assumption. Next one, the probability of success is constant. Those are the two main assumptions. One of those two. Okay, so you can say applicants being colorblind is independent. Okay, the other one you can say the probability of identifying the colorblind does not change, or there is a constant probability of a person identified as colorblind. Okay, any one of those two is fine. Okay, or you could write the other one, the probability of identifying applicants as colorblind does not change. That's a constant probability of a applicant being identified as colorblind. Okay, even that is a good assumption. Okay, next one, using a suitable approximation, find the probability that exactly 5 out of 120 applicants are identified as colorblind. So they say here the word, but using a suitable approximation. So binomial, now we need to go from binomial to either we need to go to Poisson or we need to go to normal. So here decide which one do you need to go. So here we say X follows a binomial distribution. They have said here how much? Find the probability exactly 5 out of how many? 120. So n is 120. Probability of success is 0.045. So they have told you to use a suitable approximation. Get the NP. You can decide whether you go to now basically there are two rules. When n is large and p is small, and the other one when n is large and p is close to 0.5. Those are the two things, the two parts. When n is large, p is small, we say we normally go for Poisson. When n is large and p is close to 0.5, we say we go for a normal. Basically, it depends on the mean value, EX, the expected value. So what's the NP value here? What's the NP value here? 120 into 0.045 gives us how much? It gives us 5.4. So what do you think? This is Poisson or normal? This is Poisson or normal when a value like 5.4 comes. It is Poisson. Because here definitely lambda value is less than 10. Or else in other words, you can see n is large, p is close to 0 here, right? 0.045, not 0.45. 0.45 would have been close to 0.5. But 0.045 is close to 0. So this is n is large, p is small, which means we are going for Poisson approximation here. The lambda value also is supporting that. And then you can write here what? So you can see here we follow a Poisson distribution with mean how much now? 5.4. So let's get the probability. We need to find the probability x is equal to what? That exactly 5, right? We need to find the probability exactly 5 are identified as colorblind. So let's find the probability. Do we need to do any continuity correction over here? No, because this is both are discrete. Binomial is also discrete. Going over to Poisson, which is again discrete. So there is no continuity correction that needs to be done. We can directly find the probability. So e to the power probability of Poisson distribution is e to the power minus lambda to the power x over x factorial, right? This is the probability capital X is equal to x value. So here x equal 5. So e to the power minus lambda is 5.4, lambda to the power x over x factorial. So that is 5 factorial. How much is the answer? 0.1728. Okay, so you could leave your answer to 3SF here. There's no problem. Okay. Good. Then the next one. There's more coming here, right? There are more decimals coming here. 0.1728. That's more, right? 213, yeah. So there's more. So then basically 3SF 0.173. You can leave your answer like that. Then the next one, they say, oh yeah, so we are done with this part, right? The next part, they say explain why the approximation that you use in part C is appropriate. Okay, so you have to explain why it's appropriate. Why you went from binomial to Poisson. What's the reason? N is large and P is small. So give the reason. Part D, what's the reason? There is N value is large. N value is large, P is small. Therefore, a Poisson approximation is appropriate. Okay. Why it is appropriate? Because n is large, p value is small, therefore Poisson approximation is appropriate. Okay, agreed? And the next one, they say, next part, J, okay, I'll say this as J. J claims that 75% of all applicants for this training program go on to become pilots. Okay, so he says that from this training program, 75% of all applicants, they go on to become pilots. From a random sample of 96 applicants for this training program, 67 go on to become pilots. Okay. Using a suitable approximation, test J's claim at the 5% level of significance. State your hypothesis clearly. Okay. So what's the hypothesis first of all? Okay. So first of all, what's the hypothesis? He says that 75% of all the applicants for the training program go on to become pilots. Basically, he has given the proportion here, right? So what's the proportion here? Okay, so let's say let's go to part E here and let's write the variable who is Y. Y is the number of applicants who what? Who become who go on to become pilots, who become pilots. Okay, so Y is the number of applicants who go on to become pilots, and Y follows a what distribution at this point? So we can see Y follows basically what distribution are we going to have here? I think we need to write a hypothesis first of all. So basically he says that 75% of all applicants go on to become pilots, right? So basically, let's write our H0 and H1. What is H0 and H1? H1 is P equals to what? Definitely H1 is in the form P equal, right? 0.75. And then how do we go with H1? Do we say P greater than, P less than, or P not equal? They say he claims that 75% of all applicants for this training program go on to become pilots. So from a random sample of 96 applicants for the training program, 67 go on to become pilots. Using a suitable approximation, test the claim at 5% level of significance. State your hypothesis clearly. Now, by any chance, do they say that he believes that this proportion might have increased or this proportion might have decreased? Do they say anything like that? So then we do not have any other way. So basically, I can't go with P greater than or P less than. What's the only option that I can use? Not equal. Because they do not say very specifically that he might that it might be the proportion might change or it might be great. They don't say specifically the proportion might be greater or lower. Okay, so then we have to go with not equal. And then let's talk about the distribution. This follows y follows a binomial distribution under the assumption that the null hypothesis is true. So what do we say? We have a sample of how many applicants? 96 applicants, and the proportion of success is 0.75. So they say, again, they say using a suitable approximation, right? So using a suitable approximation. So what's the approximation that we use? Can you all get me the EX value, the NP value here? Yes, we had to approximate this binomial distribution, right? How much is the EX? 72, NP is 72. So basically, very clearly you can see your NP value is quite large. Okay, your NP value is quite large. Okay, if you want, actually some of you might be thinking, can't we take probability of success, probability of failure and use 0.25? You can go with that also. Even if you use 0.25 into 96, I think still you get a quite large NP value, right? Just get that value also. In an event, if it is less than 10, we can go with Poisson. If in an event, if the NP value is less than 10, 0.25 into 96 is how much? 24. Still it's bigger than 10. So then we'll go with this. Okay, so basically what does this mean? An NP value bigger than 10 means that we go with the normal approximation. Okay, even if you go with 0.25, the number of applicants who doesn't become pilots, if you take it like that and do, even still the NP value is 24, which is bigger than 10. So anyway, you have to go with normal. So I'll go with this one. Okay, then if you're going with normal, it means I need the expected value and the variance. Can you all get me the variance X? NP times 1 minus V. Can you all get me the answer? NP is 72 times 1 minus 0.75. How much is the variance? How much is the variance quickly? Okay, so variance X is 18. So you can now write what? So you can now write the we follow a normal distribution. Mean is, okay, mean is how much? 72. And variance, okay, variance is 18. Okay, which means standard deviation is root 18. Careful here. Okay, now what do we need to find? So using a suitable approximation, test his claim at the 5% level of significance. Okay, so it's a two-tailed test. So when you take this two-tailed test, do you remember, now we need to check whether this value, what's the X value we have? From the 96 applicants, we need to check 67. We need to basically check here by using the hypothesis test. Now, you know, it's a two-tailed test, right? So you need to check whether the value of 67 goes on to any of the critical regions. That's what you need to do, okay? So you have to check whether 67 is going to the front critical region or the back critical region. Now, which critical region should I check? So in the book, you remember that when you have a two-tailed test, you need to check with one of the tails, right? So basically, check the value, your X value against the EX. What is the EX value here? 72. What's the X value we have? 67. Our X value is lesser than the expected value, right? Which means should I check the lower tail or the higher tail? Our X value is 67. The expected value is 72. Expected value is higher. Our X value is behind that. So behind means I must check the lower tail. Go with the lower tail. You get it? The other X value that we have is 67. The expected value, the mean value is 72. It's lower. Do you remember in a two-tailed test? we check the X value with against the NP value. If the X value is less, then check the behind tail. If the X value was bigger than 72, I would have taken the front tail. Do you get it? It's a theory that you learn in your book. Okay, so basically what probability am I going to find? I'm going to find the probability X is less than what? Less than or equal? Yeah, so they say here what? Less than or equal, right? From a random, yeah, we need to check whether 67 falls to the critical region. So then I have to check the probability X is less than or equal. Definitely, it's a discrete distribution at this point, right? Binomial is discrete. So I have to find the probability X is less than or equal 67 and see whether it falls onto this tail. Do you get me? I want to see whether 67 falls to this tail. Okay, so now you remember, now we are doing a approximation here. We are going from what? We are going from binomial to Poisson. Binomial to normal, which means we are jumping the boundary between discrete to continuous. So when you jump from discrete to continuous, what should you do? You must apply continuity correction. Sorry, this is not X, this is, I use the variable Y, right? Y is the number of applicants. So you must use the continuity correction. To apply the continuity correction, less than or equal 67 means what? Either this is going to be 67.5 or it's going to be 66.5. Which one do we use? Is it 67 point? Now 67, it's less than or equal 67. So should I go less than 67.5 or should I go less than 66.5? One of these two. 67.5, because if I go less than 66.5, I'm supposed to include 67 in this sum. Okay, but if you go less than 66.5, 67 is not included. This is the way that I used to remember it. Okay, it's easy in that case. So X is less than 67.5, passes through 67, and 67 is supposed to be a part of our answer. So thereby, I write Y is less than 67.5. Okay, and then what do we do here? We convert what? We need to convert this to standard normal. Convert to standard normal is this becomes Z. So from 67.5, we have to subtract the mean, which is 72, divide by sigma. Are we dividing by 18? No, by root 18. Get me this answer. Z less than 67.5 minus 72 over root 18. How much is it? Minus, how much again? Minus 3 root 2 over 4. Okay, so let's type this in the calc. You can give it directly in the calculator, right? Give the value directly in the calculator, get the probability behind. Yeah, in the normal distribution, let me show how I come here again. In this particular calculator, I go to the statistics. So different calculators have different options of getting it. So I go to normal distribution and we give p-value here. So the p-value means you get the area behind that certain figure. So number 1, P, and I give minus 3 root 2, close the bracket, divide by 4. Okay, minus 3 root 2 divide by 4, and I get here 0.14442. Okay, so 0.144 correct to 3SF. Okay, now basically, this is, what do I now remember, we are not getting a probability here, we are doing a hypothesis test here, right? So the probability X is less than or equal 67 is how much? 14.4%. By the way, how much is our significance level? We used a 5% significance level. And then because we're using a two-tailed test, each side becomes how much? 2.5%, right? So if each side becomes 2.5%, is this value? Is my value 67 falling inside the critical region here? We are checking the end tail, the left tail. So it doesn't fall, right? Because it's 14.4, definitely outside of this critical region. Do you get me? So this is greater than the 2.5%. Therefore, you can say it is inside or outside? Outside the critical region. 67 is outside the critical region, right? 67 is outside the critical region. Thereby, do we have sufficient evidence or insufficient evidence? Insufficient evidence to reject H0. There is insufficient evidence to reject H0. So thereby, and you need to definitely what I have told you, give a statement regarding the question. Okay, with respect to the question. So basically, what's the question here? This is something about J claims something, right? So you have to test J's claim. which means you have to test, say whether this claim is whether this person's claim is correct or not. So what do you think? Is there evidence to support his claim, or is there insufficient evidence to support his? Yeah, his claim is 75%. Basically, his claim is what? His claim is H0, right? Because he says 75% of all applicants go on to become pilots. Basically, this is J's claim. Okay, his claim. This is his claim. And now, are we rejecting this? Do we have evidence to reject this? No, there is insufficient evidence to reject H0, which means we can go with his claim, right? So there's insufficient evidence to reject J, or insufficient evidence against his claim. Okay, we have to go with it basically. Okay. Definitely give a statement regarding the, you can say his claim is J's claim is correct. Okay. Give the correct name. Okay. Okay, is this clear? Make sure you give an extra statement about the question, about the claim in the question as well. Okay. Okay, question number 6, they say, explain what you understand by the sampling distribution of a statistic. So basically, this is a sampling distribution, chapter 6 in your S2 book, right? So they give you definitions of several terms in the exercise. So in the textbook, so you need to remember the definition of sampling distribution from the textbook directly. You can go, right? So what's a sampling distribution? So you can give word to word from your textbook. A sampling distribution. Basically, you need to study this. Is what gives all the values of a gives all the values of a statistic, and give me the remaining thing. And the probability that each the values of a statistic. Yeah, sorry. A sampling distribution gives all the values of a statistic and the associated probabilities, something like that. Okay, so that would be a shorter version. A sampling distribution gives all the values of a statistic and its respective probabilities. Even that would be enough. Okay, you don't and the respective probabilities, you can stop from here. Okay, you don't need to go to all of this. Okay, then let's go to part B, 7-mark question. Okay, so definitely you'll have to work quite a lot here. Let's read this. At Sam's Cafe, a standard breakfast consists of 6 breakfast items. Customers can then choose to upgrade to a medium breakfast by adding 1 extra breakfast item, or they can upgrade to a large breakfast by adding 2 extra breakfast items. Okay, do you get what they're saying here? At Sam's Cafe, a standard breakfast consists of 6 breakfast items. Okay, so standard has 6 items. Customers can then choose to upgrade to a medium breakfast by adding 1 extra item, or they can upgrade to a large breakfast by adding another 2 extra items. Okay, standard, medium, and large breakfasts are sold in the ratio 6:3:2. Okay, this is what we need. Okay, a random sample of 2 customers is taken from the customers who have bought a breakfast from Sam's Cafe on a particular day. Find the sampling distribution for the total number, capital T, of breakfast items bought by these 2 customers. Show you are working clearly. Okay. So let's first of all make a small table about with respect to the number of breakfast items. So first we'll make a table number of breakfast items and the probability. Number of breakfast items and its respective probability. Okay, so tell me what are the 3 types we have here? First one is small, right? Small, medium, and in small, how many breakfast items do we have? In the small one, there's 6, right? Because they say it consists of 6 breakfast items. So and then in the medium, how many breakfast items do we have? 6 plus 1, because when you add one extra breakfast item, it becomes medium. So that's 7 breakfast items. In large, how many breakfast items do we have? 6 plus 2, you have 8. Can you also give me the, this is not the probability distribution. This is just the idea for us, because I need to have the X values and the probability of X. Okay, so what's the probability of a small item? Of a customer eating a small item? They have told here the selling ratio 6 to 3 to 2. So 6 out of how much? Add all the 6, 7, 8, 9, 10, 11. So basically 6 out of 11 that you order a small breakfast. Then the next one, 3 out of 11 you order medium, and 2 out of 11 that you order a large. So probability we'll write here capital X is equal to X. So simple X values are 6, 7, 8. Okay. Right. So basically you have the probability of each item and their respective probabilities. Okay. Now what are we supposed to do? This is not what we are supposed to do. We are supposed to get what? They say a random sample of 2 customers is taken. They are taking a random sample of 2 customers who have bought a breakfast from Sam's Cafe on a particular day. Find the sample and distribution for what? For the total number, capital T, of breakfast items bought by these 2 customers. Basically now each customer can either buy 6 items, 7 items, or 8 items. So basically you need to get your 2 customers, X1, X2, and like create a table for all the possibilities that they buy. You get me? Okay, so then, and then capital T represents what? The total number from these 2. The addition of this is the capital T, and you have to get the sample distribution with the capital T here. So there's quite a lot to write here, right? Okay, so then what are the items we can take here? Tell me. Both of them can take small, 6, 6. Okay, so then total is how much? 12. Okay, and then the probability. How do we get the probability? Multiply the probability of getting a small breakfast is 6 over 11. Again into 6 over 11, right? Which is the how much? 36 over 121. Okay, then go to the next one. Tell me the next one. We can go with what? 6 and 7. 6 and 7. So total is how much? 13. By the way, now to make your life a little bit easier, you do realize when you take 6, 7, we can also take what? 7, 6. Because 6, 7, 7, 6 are, I mean, we have to take every single possibility, right? So 6, 7 also includes what? 7 and 6. Basically, the thing is what I'm trying to say here is both of them are 13. We can take them together as one bundle and get the probability of both of them together. Okay, so what's the probability for one path? 6 is 6 over 11. 7 is 3 over 11. And how many paths? There are 2 paths like that. Or else you can write each path individually and get, since both of them are the same thing, I'll write once and just multiply by 2 for both the paths. How much is the answer? Can I know the answer here? Again, 36 over 121. Okay, next one. Let's go for another option. 6 and 8. Okay. Yeah, so 6 and 8 definitely goes together with what? 8 and 6. Do you agree with me? Get me the answers. What's the total of 6 and 8? 14. So both of these paths give me a total of 14. Get the probability. 6 is 6 over 11. 8 is 2 over 11. And then there are 2 such paths, which is how much? How much is it? 24 over 121. Okay, then the next part, we can take what? The next one we'll go with 7. Now I have written everything with 6, right? Every possibility with 6 is written. Now the next one, 7, 7. Start with 7, 7. 7, 7 is a path that goes alone. So get 7, 7. What's the probability of 7 and 7? That is 14. Get the probability. 7 is 3 over 11 times 3 over 11. No other possibilities are there, right? 3 times 3, 9 over 121. Do you agree? Then the next one, along with 7, we can go 7 and 8. 7, 8, which means also we need to take 8 and 7. Because we are getting the total, both of them give me the same total. That's why I'm writing them together. Okay. So what do we get here? The total of 8 and 7 is 15. 15. Can I know the probability? 7 is 3 over 11 into 8 is 2 over 11. And how many? 2, which gives me 12 over 121. Are we done yet? No, there is a, do I need to take, by the way, now I took 7. Do I need to take 7, 6? No, we have already taken it. Right? So the next part is 8, 8. And basically after 8, 8, do I need to take 8, 7 or 8, 6? No, it's already considered. So I only need to have one more part and then we are done with this. We can take 8, 8 quickly. Okay, so 8, 8 is 8 plus 8 is 16, right? 2 over 11 into 2 over 11, which is? Okay, so you can do a quick test whether you have done this correctly. Basically, if you add all the probabilities in this table, it must add up to what? 1. If it doesn't add up to 1, it means you have definitely missed the part. It must add up to 1 and then you know you have done it correctly. Okay, but anyway, I need to get the probability distribution of T. So probability, the oils, you can get the total probability of the probability distribution of T. If you get it from here itself, you know where you have missed the path or not. Or else you have to make the table, T distribution table, and then see whether the total probability becomes 1. Okay, so let's get the probability of T. So you have here capital T values and probability capital T equals to T. So let's get the table. The probability distribution of T, you have to give the T values and the associated probabilities of T. Okay, so what are the T values we have? We have 12. Go in ascending order. 12, then 13, 13, 14, 15, 16. Okay, yeah, that's it, right? So these are the X values we have. Can you tell me the probability of 12? There's only one path for 12, which is 36 over 121. For 13, we have 2 paths. I think we got both the paths together, right? Which is again 36 over 121. For 14, I think you can see here we got the 2 paths here, but there's another path, 7, 7 also. Basically, 24 over 121 plus 9 over 121, which is how much? 24 plus 9 is 33 over 121. Okay, 15. 15 is how much? The 2 parts. I have taken both the parts together because I have multiplied by 2. So it's what? 12 over 121. 16 is 4 over 121. You can add all the probabilities and check whether it adds up to 1. If it adds up to 1, you have done this correctly. Do you agree with me? So this is how we make the probability distribution of T. We can 33 over 121 is can simplify here. Yeah, 33 over 121 simplifies to give you how much? 3 over 11. Okay, so 33 over 121 is also correct. 33 over 121 simplifies to give 3 over 11. Okay, then the next one they ask you, find dt, expected value of t. So how do we get the expected value of? Basically, you multiply the t value with the probability. 12 times 36 over 121 plus 13 times 36 over 121 plus 14 times 3 over 11 or 33 over 121. 15 times 12 over 121. Then 16 times 4 over 121. How much is it? 146 over 11, which to 3SF? 13.3. Basically, this is an exact answer. You could leave it exact. 3SF 13.3. Is this clear? Okay, moving on to question number 7. The sides of a square are each of L centimeters and its area is A square centimeter. Do you see what they say here? There's a square, each side is L centimeters. So the area is A. Basically, what does it tell you? Area is equal to L into L, which means area is L square, right? Given that A is uniformly distributed on the interval 10 to 30, basically they have given you the distribution of A. Okay, given that A is uniformly distributed on the interval 10 to 30, find the probability L is greater than 4.5. So basically, if you want to find the probability L is greater than or equal 4.5, how do we find it? Now they have given you the uniform distribution of A, the area. So how can I convert this L to area? You know, area is L square, right? L into L. So how do I convert 4.5? Square the 4.5. When you square the 4.5, what do you get? Can you square 4.5? 20.25. So basically, if your length is greater than 4.5, now for equal 4.5, area is equal 20.25. When your length is more than 4.5, area is going to be less than or more than? More than, right? Because when the length gets bigger, the area also gets larger, isn't it? So greater than or equal 20.25. Can't you get this area by using this particular interval? You can, right? So basically, area is following what distribution? Uniform distribution on the interval 10 to 30. And then the y value here is 1 over b minus a, right? What's 1 over b minus a? 1 over 30 minus 20 is 1. 30 minus 10 is 1 over 20. Do you see? This is the rectangular distribution. So area greater than 20.25 is basically, you have to get the area from where to where? From 20.25 to 30. You have to get this area. That area is what we need. So 30 minus 20.25 is the length, into width is 1 over 20. Do you understand? Because it's a rectangular distribution and we use this, the y value of the distribution is found by 1 over b minus a, 1 over 30 minus 20. That's the height of the rectangle, 1 over 20. So area greater than or equal 20.25 is the area of the small rectangle that I colored. 30 minus 20.25 is the length. The width is 1 over 20. How much is the answer? 0. Exact answer. 39 over 80, which is equal to 0.4875 exactly. Oh yeah, then don't round it off. Okay, because it's a exact answer. Okay, don't make it 3SF in that case. Okay, only those large answers you round to 3SF. Otherwise, these kinds of answers, give it exact. Then part B, find the variance of L, and you can see for variance L, they have given you how many marks? 6 marks. Always look at the number of marks when you answer a question, because that tells you the gravity of the question and how much working you need to do towards getting this question. Okay. So basically, variance of L is what? Variance of L is EL square minus EL whole thing square. Okay, so now the thing is, you have the distribution of the area, right? So you have to get the what? You have to get the EL square value and the expected value of L. Okay, so how do we get the expected value of L? Okay, how do we get the expected value of L? The thing is, you can't use a plus b over 2 here. The reason being, the uniform distribution is on the interval 10 to 20, and that's for the area. That's for the area. Okay, but the thing here is what is the relationship between L and A? If area is equal to L square, then L is equal to root A, right? So L is equal to root A. Okay, so then, okay. So to do this question, to get the expected value of root A, what you can do here is, we will go with the definition of EX. Okay, so don't go to, this is the best way of doing the question. EX is what? EX is x fx, right? You multiply x with the fx with respect to x, and the lower limit and upper limit are actually the lower and upper limit of the interval, the interval that they have given you here. Okay, so basically what we do here is to get E of root A. So what this is like basically EX. So here X is what? Root A. X is root A. So what can we do here? So we can, and by the way, what's our fx? The fx is, by the way, what's our fx here for A? What is the fx function? Or we can say fa. Who is our fa function? 1 over 20, right? 1 over b minus a, isn't it? It's 1 over b minus a. This is our fx, isn't it? 1 over b minus a, and this was defined for a values from where to where? This was defined for a values from 10 to 20 and 0 otherwise. This is our uniform distribution, isn't it? 10 to 30, sorry, 10 to 30. This is our uniform distribution. Am I correct? 1 over b minus a, 1 over 30 minus 20. This is our fa from 1 to 20. Okay. So E root A is going to be what? E root A is going to give you what? Okay, so now listen to this. So you can see if you have EX square, it's x square into fx, right? Do you see it? Now I wanted to get E root A. So if it's EX square, we get x square into fx. We don't change the fx here. Can you see? So if I take E x cube, it's going to be what? Integration x cube times fx, right? We don't change the fx. So basically E root A means what? Integration of x to the power, or in this case it's root A. So root A times your fa with respect to A. Do you get what I'm saying here? The variable letter has changed, but the method is exactly the same. Okay, so if you have basically I use this rule. If it's square, it's x square fx, right? You write the fx as it is. You don't change it. You get it. If it's x cube, then x cube times fx. Likewise, this is root x. So if you have E root x, here E root x means what? Root x times fx. Do you see it? So that's exactly what we do here. E root A means root A times fa. We don't do anything for the fa. Fa is already defined now. So get the values here. Root A times what's our fa? Fa is 1 over 20. And our limits for fa function is from 10 to 30. Do you realize what's going on here? Basically understand the definition of EX. EXN, basically you can, the XN rule is given to you, right? E to the power XN is integration x to the power n times fx. Are you with me? This rule. Use this rule. So basically here x to the power half means x to the power half times fx. So here just that the variable letter has changed from x to a. That's all. Okay. So get the integration now. 1 over 20 is a constant, can be taken out. Root A needs to be integrated. Can you all integrate root A? A to the power half plus 1 is 3 over 2. Divide by 3 over 2. Limits are from 10 to 30. So 1 over 20 into 2 over 3. A to the power 3 over 2, 10 to 30. You have to give the limits, right? So give the limits. I took the constant out here. Divide by 3 over 2. Came up as 2 over 3. 1 divided by 3 over 2 is 2 over 3. This cancels. I get 1 over 1 over 30. So I get here 30 to the power 3 over 2. Replacing A with 30. Then replacing A with 10. 10 to the power 3 over 2. How much do we get? Can you all simplify and get me the answer? How much is it? Get me the decimal answer. I think you get a decimal answer here. 1 over 20, 1 over 30 into this answer, right? So we get 4.4231. Can you tell me? Keep on going. 0, 2. Okay, something like this. Just write the full thing because this is not the final answer. We are supposed to get variance of L, right? So I just got the EL value here, expected value of L. Now I need to get the expected value of L square. How do I get the expected value of L square? L square is actually what? L square is A, right? So do you think it's difficult to get the expected value of A? No, we know A follows a uniform distribution, right? From 10 to 20, from 10 to 30. So for a uniform distribution, if you want to find the expected value, it's simply you add the two limits and divide by 2 because it follows the uniform distribution, right? You can directly go. So EA is you add the two limits 10 plus 30, add and divide by 2. Do we need to go with integration? If you want, you can go with integration. Basically, EA would give you integration of A times FA with respect to A. You can go with this. But since it follows the distribution, uniform distribution properly, we don't need to go with that. Okay. So you can use that integration if you want, or basically use 10 plus 30 divided by 2. How much is it? 20. And you can get EL square quite easily. Now get variance L. So variance L is EL square minus EL whole thing square. EL square is 20 minus this answer is 4.42313302. Just give the whole value, square it. Can I have the answer here? Yeah, final answer you can give it to 3SF. 0.436 is your final answer to 3SF. Is this clear? I hope all of you were really clear on how to find the E of root 10, okay, by using the rule here. These rules, how we manipulated and used the rules. Okay? Okay, so this is the end of the January 2022 S2 paper.